My dear students, today I am going to discuss geometry for class 9 from the chapter of lines and angles. So in the beginning, let me discuss some basic concepts. Now, what do you mean by collinear points? Now, collinear points means points which lie in a straight line. Now, 2 points always lie in a straight line. Therefore, 2 points are always collinear. But 3 points may not be collinear. So these 3 points may not be collinear. So these three are not collinear, but these three are collinear. So these 3 points are collinear, but these three are not collinear. So collinear points means points which lie in a straight line. Then arms of an angle. Now this is an angle. So ABC is an angle. Now for this angle, this is called vertex. This B is called vertex. Vertex or angle point. And AB and BC, these two lines are called arms. So an angle has a vertex or angle point, and it has two arms. Here AB and BC are arms. All right. Then different types of angles. So this angle is acute angle. Acute angle is less than 90. So x is less than 90 degree. So this is acute angle. Now this angle. So this angle is obtuse angle because it is more than 90, but less than 180. So less than 180, but more than 90. So acute angle is less than 90 degree, and this is obtuse angle. Obtuse angle is more than 90 degree, but less than 180 degree. Then this one is straight angle. Straight angle. So on a straight line, any angle on a straight line is a straight angle. Suppose this angle is this angle. Let us call it M. So angle M. So angle M is what? Straight angle, because this is a straight line and this angle is formed by that straight line. All right. Then reflex angle. Now this is reflex angle. So this angle is X, acute, but this angle is, suppose, angle P. This angle. So this angle P is reflex. Angle P is reflex. So reflex angle is one which is less than 360 degree, but more than 180 degree. So this is less than 90 degree. This is more than 90 degree, but less than 180 degree. This is equal to 180 degree. So this is equal to 180 degree. And this one is more than 180 degree, but less than 360 degree. So angle P is what? Angle P is less than 360 degree and more than 180 degree. So reflex angle is one which is more than 180 degree, but less than 360 degree. All right. Now reflex angle and acute angle together 360 degree. So this whole angle is 360 degree. Okay. All right. Now coming to next, pair of angles. So we have several pairs of angles. Now these two angles. So this is angle X, this is angle Y. Now X and Y are adjacent angles. Adjacent angles. Now two adjacent angles have one common vertex. This is a common vertex, suppose P. So P is the common vertex. And it has a common arm, suppose PQ. So PQ is the common arm. PQ is common arm. So adjacent angle are those which have a common vertex and common arm. So this is a common vertex. Both the angles have this vertex common and they have one arm common. These two are uncommon arm. So this and this, they are uncommon arms, but this is common arm. So one common arm and one common vertex. So this is called a pair of adjacent angles. Okay. Then if two straight lines intersect, we get vertically opposite angles. Now these two straight lines are intersecting at point O. This is a point O, suppose. This point is O. So two straight lines are intersecting at this point O. Then we get two pairs of vertically opposite angles. So this angle X, this angle Y. So this X and Y is first pair of vertically opposite angles. Then suppose this is M, this is N. So this angle and this angle, that is another pair of vertically opposite angles. Vertically opposite angles. So when two straight lines intersect, we get two pairs of vertically opposite angles. So these two are vertically opposite angles, first pair, and the second pair is this MN, vertically opposite angles. All right. Then linear pair. Now when one straight line stands on another, suppose this is a straight line AB and a straight line CD stands on it, CD. So when one straight line stands on another straight line, we get a pair of linear angles. So that is called linear pair. All right. Now this angle. So this angle, suppose X we call, and this angle we call Y. So X and Y, X and Y. So that is linear pair. So this is an important axiom. When a straight line stands on another straight line, we get two adjacent angles. These two adjacent angles have a common arm D, common vertex D, and one common arm CD. And they are called linear pair. And because their sum is 180 degree. So X plus Y equal to 180 degree. So sum of linear pair is always 180 degree. Okay. So these two are called linear pair and their sum is 180 degree. All right. Okay. Then comes alternate angle and corresponding angle. Now consider these two straight lines. So straight line AB, straight line CD, CD, and straight line PQ. So AB and CD are two straight lines. Now whether they are parallel or not, we do not know. Simply straight lines. They may be parallel, may not be parallel. All right. So here I am drawing non-parallel. So you look at them, they do not look parallel. So AB and CD are two straight lines, and the third line PQ cuts them. So this third line is called transversal. So this line which cuts AB and CD, that line is called transversal, and these two are straight lines. Now these transversal cuts AB at suppose L and CD at M. So this point is M, this point is L. So transversal PQ intersects AB at L and CD at M. Now these two angles, so this angle and this angle, all right. So let me name them. So let me name the angles first. So this is angle 1, this is angle 2, this is angle 3, this is angle 4. Then this is angle 5, this angle is angle 6, this one, this is suppose 7, this is 8. So angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. So these four, there are how many? 8 angles. Now this angle 4 and 5, That is a pair of corresponding angle. 4, angle 4 and angle 5. So they are corresponding angles. Corresponding angles. All right. So there are 4 pairs of corresponding angles. See, I have named one pair. This angle and this angle. That is one pair of corresponding angles. Then this angle, angle 1 and angle 8. So angle 1 and angle 8. So they are another pair of corresponding angle. So 1 and 8, that is one pair of corresponding angles. 4 and 5, that is another pair of corresponding angles. Then this side 3 and 6. So 3 and 6, another pair of corresponding angles. Then we have 2 and 7. So 4 pairs of corresponding angles. Which 4? 1 and 8. This one and this one. 1 and 8. Then 3 and 6. This one and this one. 3 and 6. Then 2 and 7. This one and this one. 2 and 7. And then 4 and 5. So this 4 and this 5. So we have 4 pairs of corresponding angles. Now to remember corresponding angles, there is a trick. So suppose just imagine the letter F, or imagine the letter F this way. So this is F, this is inverted F, isn't it? Now this angle, this is one pair of corresponding angles. This is one pair of corresponding angles. Now if you say this one, so this line and this line and this line, that looks like an F. This F. So this one and this one, you see, that is one pair of corresponding angles. Similarly, if you see this one, this line, this line, this line and this line, it is like this. This, you see, this line, then this line and this line. Now this and this, that is a pair of corresponding angles. See, this and this. So that is how you can find out. So letter F or inverted F. Okay. So we have 4 pairs of corresponding angles. Okay. All right. Now 2 pairs of alternate angles. 2 pairs of alternate angles. So suppose again these two are, this is transversal. So suppose AB, CD, all right, say PQ. So PQ is a transversal and AB, CD are 2 straight lines. Then again let me name it. Suppose this is 1, this is 2, this is 3, this is 4. This is 5, this is 6, this is 7, this is 8. So now look at that diagram. So there are 8 angles, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now alternate angle is this one, this 1 and 6. So 1 and 6, angle 1 and angle 6. So they are alternate angles, alternate angles. All right. 1 and 6. Then there is another pair, 2 and 5. 2 and 5 are another pair of alternate angles. So this one and this one. So this on the left, this on the right. One is on the left, other is on the right. That is one pair of alternate angles. Alternate, isn't it? Then this is right, this is left. So these two are second pair of alternate angles. So there are 4 pairs of corresponding angles which you already saw, and there are 2 pairs of alternate angles. Which 2 pairs? 1 and 6 and 2 and 5. All right. Now here also is there is a trick to remember. So remember the letter Z. So this and this, you see, this and this alternate angles, or suppose this one, Z. So this angle and this angle are alternate angle. Now look here, this one, you see. So this one and this one alternate angle. Then another. So this one and this one alternate angle. So if you see the letter Z, this and this one pair of alternate angle, and this another pair of alternate angles. So when 2 straight lines are intersected by a transversal, what do we get? We get 2 pairs of alternate angles and 4 pairs of corresponding angles. Okay. All right. Now co-interior angles. Okay, now look at this diagram. So AB and CD are intersected by transversal PQ. So angle 1, angle 2, angle 5, angle 6, so that way. Now this 1 and 5, that is one pair of co-interior angles, co-interior. So 1 and 5 is the first pair of co-interior angle, and the second pair is 2 and 6. So there are two pairs of co-interior angles. Now interior means they are between the straight lines. Say this is one straight line, this is another, just between them inside. So that is I call interior. And co means on the same side of the transversal. So 1 and 5, they are on the same side of the transversal, on left side. Then 2 and 6, they are on the same side of the transversal, that is right side. All right. So this 1 and 5, they are one pair of co-interior angles, and 2 and 6, the second pair of co-interior angles. So what you saw, when two straight lines are intersected by transversal, we get 4 pairs of corresponding angles, 2 pairs of alternate angles, and 2 pairs of co-interior angles. Okay. All right. Now let me next go to axioms. Now axioms are those facts in geometry which do not require any proof. I followed? Now those statements which require proof, they are called theorems. And those statements which do not require proof, they are called axiom, postulate, and all that. So now we'll see some postulates, some axioms of geometry in this chapter. All right. Now axiom 1 is this one. Axiom 1. The first axiom 1 is this. When a straight line stands on another, then the sum of the two adjacent angles is 180 degree. So angle x plus angle y equal to 180 degree. So that is axiom 1. When a straight line stands on another straight line, then we get two adjacent angles, and sum of these two adjacent angles is 180 degree, and these two angles are called linear pair. So I already explained this one before, linear pair. So when a straight line stands on another straight line, making two adjacent angles, the sum of the two adjacent angles is always 180 degree, and the two angles are called linear pair of angles. So this is axiom 1. Now axiom 2. Axiom 2 is the reverse of this, converse of this. Axiom 1 and axiom 2 are converse of each other. Now axiom 1 says if these two are linear pair, then their sum is 180 degree. All right. Then the axiom, the converse is this: if the sum is 180 degree, then this is a straight line. That means if sum of two adjacent angles, is 180 degree, if sum of two adjacent angles 180 degree, then the non-common arms. Now you see these two are adjacent angles. This is the common arm. This suppose AO. AO is the common arm. OB and OC are uncommon arm. These two are adjacent angles. This is the common arm. This is the common vertex. OB and OC are uncommon arms. Right? Now the axiom 2 says if the sum of two adjacent angles is 180 degree, then the uncommon arms lie in a straight line. That means BOC is a straight line. BOC is a single straight line. Not two straight lines, but single. Why BOC is a single straight line? Because sum of these two angles 180 degree. So you see axiom 1 says the sum of two adjacent angles, when one straight line stands on another, sum of two adjacent angles is 180 degree. And what is the converse? That is axiom 2. If the sum of two adjacent angles is 180 degree, then these two outer arms, there is non-common arms, must be in a straight line. That means this BOC is a straight line. That is axiom 2. These axioms, there are two more axioms we will be using frequently in proving theorems. All right. Okay, now axiom 3. Axiom 3 is this one. It is two parallel straight lines intersected by a transversal. So axiom 3 is this. Axiom 3. So this axiom says if two parallel straight lines are cut by a transversal, say AB and CD are two parallel straight lines. AB and CD are two parallel straight lines, and suppose PQ intersects them, PQ cuts them. AB and CD are two parallel straight lines and PQ transversal intersects them. Then this axiom says corresponding angles are equal. So suppose this is okay, let us say number 1, 1, 2, 3, 4, 5, 6, 7, 8. So this is angle 1, this is angle 2, angle 3, angle 4, like that. So this axiom says if two parallel straight lines are intersected by a transversal, then corresponding angles must be equal. Corresponding angles must be equal. So this 1 and 5, they are corresponding. So angle 1 is equal to angle 5. Angle 1 and angle 5, they are one pair of corresponding angles, and according to this axiom, they must be equal. Then this 2 and 6, second pair of corresponding angles, so they must be equal. Angle 2 equal to angle 6. Angle 1 equal to angle 5, angle 2 equal to angle 6. Then on this side, this angle 4 and angle 8, they are equal. Angle 4 equal to angle 8. All right. And then the last pair, this one, angle 3 and angle 7. So angle 3 equal to angle 7. All right. So these two angles are corresponding pair, so they are equal. These two angles, second corresponding pair, they are equal. Then 4 and 8 corresponding pair, they are equal, and 3 and 7 corresponding pair, they are equal. So when two parallel straight lines are intersected by a transversal, then the four corresponding pair of angles, the angles are equal. All right. So they are equal. Because why? Because these two are parallel. Now next axiom is just the converse of this. So axiom 4 is converse of axiom 3. So now axiom 4. All right. Now axiom 3 says, so listen carefully, axiom 3 says these two lines are parallel, this is transversal, and corresponding angles are equal. Now the converse will be, if corresponding angles are equal, then lines are parallel. That means if. So you see, if this is true, then we conclude what? Then we conclude AB must be parallel to CD. That is the axiom 4. If corresponding angles are equal, then the two lines must be parallel. That is axiom 4. So axiom 3 is if AB and CD are parallel, then corresponding angles are equal. Just the converse, if corresponding angles are equal, then the two lines must be parallel. So these are the 4 axioms in this chapter. As I told you, you'll be frequently using them in proving theorems and riders. Okay. All right. Now let us see the theorem 1. First theorem. First theorem. So there are altogether 8 theorems. There are altogether 8 theorems. 8 theorems are there. Now let us see how far we can do today. All right. Okay, now theorem 1. Theorem 1. Now theorems are those statements in geometry which require proof. We must prove them, right? Now the theorem 1 says vertically opposite angles are equal. Vertically opposite angles must be equal or equal. So this theorem says vertically opposite angles are equal, and in the examination you will be asked to prove it. So prove it. So prove this statement. Which statement? Vertically opposite angles are equal. So the question will come this way: prove that vertically opposite angles are equal when two straight lines intersect. So this is a diagram. So suppose A, B and C, D are two straight lines. So they intersect at O. All right. So vertically opposite angles are equal, you have to prove. So what is given? A, B and C, D are two intersecting straight lines. They intersect at O. So we have to prove. We have to prove what? To prove this equal to this. To prove AOD equal to COB. To prove AOD equal to COB. To prove AOD equal to COB, that is one pair of vertically opposite angles. And also we have to prove AOC equal to DOB. AOC equal to DOB. So what is given? That given part I have not written. So what is given? AB and CD are two intersecting straight lines. They intersect at O. Now required to prove. What is required to prove? This angle equal to this one, and this angle AOC equal to DOB. All right. Now proof. This is how you have to write theorems. First of all, given. Now that given part I have not written. Then required to prove. What to prove? And then proof. Sometimes construction is necessary, but for this one no construction required. Okay. Now see. Now AO is a straight line which stands on DC. So we are going to use axiom 1. When a straight line stands on another straight line, they form linear pair and their sum is 180 degree. All right. So AO stands on what? AO stands on DC. All right. Therefore, according to that axiom 1, these two are linear pair. Their sum is 180 degree. That means AOD plus AOC. So these two together must be 180 degree because they are linear pair. So this within bracket you have to give reason because they are linear pair. Now in proof, whatever statement you write, you have to give reason. Okay. So AO stands on DC. Therefore these two are linear pair and their sum is 180 degree. This is according to axiom 1. All right. Again, similarly, if you see, now we can say CO stands on AB. So CO stands on AB. Therefore, sum of these two will be 180 degree. CO stands on AB. So that part you will write. Similarly, CO stands on what? AB. CO stands on AB. Therefore, sum of these two angles 180 degree. Which two angles? Angle AOC plus angle COB. Angle COB. So their sum is 180 degree. Again, what reason? Linear pair. Linear pair. That is axiom 1. So sum of these two angles 180 degree. The reason is they are linear pair, and sum of these two angles 180 degree because the same reason, linear pair. All right. Now if you say 180 degree, 180 degree. Now from these two statements, what we can write? This plus this equal to this plus this, because this plus this is 180 degree, this plus this 180 degree, 180 degree, 180 degree, same. Therefore we can write AOD plus AOC. So what we can write? AOD plus AOC. Therefore we can write, I am writing here, therefore AOD plus AOC. AOD plus AOC equal to AOC plus COB. Equal to AOC plus COB. Why? Because they are both equal, this 180 180 same, therefore this equal to this. Okay, now use rule of equation. This AOC from both sides you cancel. This is rule of equation, therefore what is left? AOD equal to this side COB. So we have proved AOD, this one equal to COB. So we have we had to prove this. So vertically opposite angles are equal. All right. So we have proved this equal to this. Now exactly similarly we can prove this equal to this. So that details you are not to write, not necessary to write. So the remaining thing, how will you write? Simply similarly. Similarly we can prove. Similarly we can prove. Similarly we can prove what? The other pair. That means AOC equal to DOB. AOC equal to DOB. So this is how you have to write and conclude the proof. So for theorem and rider, the question will be given. Now read the question properly and see what thing is given and what to prove. So accordingly we will draw the figure. We will draw the figure. Now if you have drawn the figure correctly, that means half the work is done. All right. So draw the figure correctly, then write what is given, what to prove, and finally the proof. That is the way to write a theorem or a rider. Okay. All right. This was theorem 1. Now theorem 2. Let us see theorem 2. Let us see theorem 2. So as I told you, there are 8 theorems in this chapter, class 9. So let us see how much you can do today. Okay, now theorem 2. Theorem 2 says, if a transversal intersects two parallel lines, alternate angles are equal. So if a transversal intersects two parallel lines, then alternate angles must be equal. That is the statement of this theorem. If a transversal intersects two parallel lines, then the alternate angles must be equal, and that is what you have to prove. What you have to prove? Alternate angles are equal. And what is given? A transversal intersects two parallel lines. So this is the diagram. These are the two parallel lines. This is the transversal. So AB and CD are two parallel lines, and suppose PQ is the transversal. PQ cuts AB and CD at R and S. So for the answer you will write given. So first you will write given. What is given? AB and CD are parallel lines. PQ is the transversal. PQ intersects AB at R and CD at S. That is what you will write. Again I say what you will write in given. AB and CD are parallel lines. PQ is transversal. PQ intersects AB at R and CD at S. All right. That is the given thing. Then next you will write to prove. To prove. Now what to prove? Yes, you have to prove alternate angles are equal. You have to prove this part. Alternate angles are equal. That means you have to prove this angle equal to this angle. ARS. You have to prove ARS equal to ARS. This angle equal to this angle. Z, as I told you before, alternate angle Z. This equal to this RSD. RSD. And this angle equal to this angle. That means BRS, and BRS equal to RSC. So you have to prove these two things. ARS equal to RSD. This equal to this, and BRS and BRS. This one is equal to RSC. RSC. Yes. Okay. So alternate angles equal. You have to prove. All right. Now the proof part. Okay, now here we are going to use that axiom. So that axiom 3, axiom 3, what was axiom 3? If two parallel lines are cut by a transversal, then corresponding angles are equal. That axiom. If two parallel lines are intersected by a transversal, then corresponding angles are equal. So that axiom we are going to use to prove alternate angles equal. Okay. So proof, now you see AB parallel to CD. So since AB parallel to CD. Now AB parallel to CD, when you write in exam, you have to write the reason that is given. As I told you in the proof, when you write the proof, for every statement within bracket you have to give reason, unless it is obvious. Now AB parallel CD, it is not obvious, but it is given. In the question it is given, you see, AB the parallel given. So you have to give the reason what given. And then transversal, what is transversal? PQ is the transversal. PQ is the transversal. So AB and CD are parallel given and PQ is transversal. All right. Therefore, using axiom 1, what is equal? This angle is equal to this angle. That means PRA. Therefore, PRA. This angle is equal to this angle is equal to this angle. That is RSC. RSC. So, what reason you will give? Their corresponding angle. Corresponding angles. So, using axiom 3. So here you don't have to write axiom, what is axiom and all that. So you just write corresponding angles. Their corresponding angles are equal. You can write full statement corresponding angles are equal, or it is enough to write corresponding angles. So why these two are equal? PRA equal to RSC because they are corresponding angles. Okay. Okay. Now, yes. Next, corresponding angles. This equal to this. Next, you write again, you see these two are equal. They are vertically opposite angles according to theorem 1. In theorem 1, we have already proved vertically opposite angles are equal. Again, PRA equal to, PRA is equal to which angle? This angle. This angle means BRS. What reason? Again, reason you have to give vertically opposite angles. VOA. I mean, rightfully, I am writing in brief VOA, vertically opposite angles. So these two are equal because they are corresponding angles, and these two are equal. Why? Because they are vertically opposite angles. I followed. Now you compare these two statements. And see what you come to. So PRA equal to RSC, and again PRA equal to BRS. Therefore, don't you think these two will be equal? See, this angle equal to PRA and this angle equal to PRA. Therefore, they are equal, isn't it? So, therefore, what we conclude? These two are equal. That is BRS equal to RSC. So, we have proved it. We have proved this equal to this. So, they are alternate angles, isn't it? So, we have proved the first pair. Next, we have to prove this pair. All right. So, comparing these two. So, PRA equal to RSC, again PRA equal to BRS. Therefore, RSC equal to BRS. So, these two equal, we have proved. Now, similarly, so the other part you don't have to write details. Similarly, we can prove what? Similarly, we can prove this ARS angle equal to what? RSD. So similarly, we can prove this angle ARS equal to RSD. So done. This is how clearly you have to write the proof. All right. So this was the theorem 2. Theorem 2. All right. Okay. Now, as I told you, there are 8 theorems. Okay. Then theorem 3. Quickly, let us do theorem 3. So let us do theorem 3, then we'll stop for today. Okay. Now theorem 3 is converse of theorem 2. Now since it is converse, I'd like to do today. All right. Now theorem 3. Theorem 3 is converse of 2. Converse of theorem 2. Now two theorems are called converse of each other if what is given in one theorem is required to be proved in the other theorem, and what is required to prove in one theorem is given in the other theorem. I followed? Given and required to prove. So in theorem 2, what was given, that will be required to prove in theorem 3, and in theorem 2, what was required to prove will be given in theorem 3. So that is how, two theorems are called converse of each other. Now here, this is the, now converse theorems have exactly same diagram. Converse theorems have exactly same diagram. So see, this is the diagram like before, A, B, C, D, P, Q, this is R, this is S. All right. So here what is given? What is given? What is given? Alternate angles are equal. That means ARS. ARS. So it is what is given? ARS equal to this angle equal to this angle given. ARS equal to RSD. So if you recollect, this was to be proved in theorem 2, but in theorem 3, this is given. And then what to prove? What to prove? To prove lines are parallel, to prove AB parallel CD. AB parallel CD. Now in theorem 2, parallel was given and this was to prove. But in theorem 3, this is to parallel to prove and this is given. Just converse. Okay. Yes, now see how to do it, the proof. Okay. Now ARS equal to RSD. That is given, isn't it? Yes. So now ARS equal to RSD. This is given. This is given. This is given. All right. So this equal to this given, and this equal to this because they are vertically opposite angles, and we know ARS equal to what? PRB equal to PRB. Why? Because they are vertically opposite angles. In the exam you write fully vertically opposite angle, so I am writing briefly. So this equal to this was given, and this equal to this. Why? Because they are vertically opposite angles. Two lines intersect, vertically opposite angles are equal, isn't it? Now compare these two statements. So RSD equal to ARS, PRB equal to ARS. Therefore these two must be equal. Therefore what we get? RSD. Therefore we get PRB. This PR. Let us write PRB first. PRB equal to what? RSD. RSD. All right. So PRB equal to ARS, RSD equal to ARS. Therefore, these two must be equal. So which two must be equal? PRB, this one and this one equal. Now are not they corresponding angle? Because this is F, this is inverse F, you see. So these two are equal, we have proved. Now according to axiom, which axiom? According to when these corresponding angles are equal, when corresponding angles are equal, then lines are parallel. Axiom 4. So according to axiom 4, now what you can conclude? AB parallel CD. Because we have proved corresponding angles are equal. So these two are equal, but they are corresponding. So, but that is how you will write in exam. But these angles are what? These angles. These two angles are corresponding angles. Corresponding angles. So these two are equal, we have proved, but these two are corresponding angles. Therefore, what we conclude, I am writing here. So therefore, what we conclude? Yes, AB parallel CD. AB parallel CD, and that is what we had to prove. So what was to prove? You see, to prove AB parallel CD. So using that what you call axiom 4. So these two we have proved equal, but they are what? Corresponding angles, and that axiom says if corresponding angles are equal, lines must be parallel. So AB parallel CD, and that was what we had to prove. So done it. So this is theorem 3. So 2 and 3 are converse of each other. So tomorrow in my next video, I will proceed from theorem 4. 4, 5, 6, 7, 8 up to 8. Okay. Okay, for today then. For today. So as it is. So if you are happy with this, please subscribe to my channel. Okay. All right, for today.